Hi everyone, how are you? This is Mari Carmen and I am translating a tutorial made by Gabriela Carita. In this tutorial we will talk about the determination of the vegetation and biomass indices. We know that the use of satellite images and aerial photos are a good technique to analyze the vegetation. This allows to get quantitative information of the state of the vegetation and the spatial variability of a study area. The indices are used to estimate different changes in the vegetation, biomass, and chlorophyll, for example. In this tutorial, we will learn how to estimate the relation of biomass with the NDVI and the green-red normalized difference index. We have selected the study area of a lake in California. Okay, so I'll show you the lake in California. This is the study area. And we downloaded the satellite images from the semi-automatic classification plugin. You can download the plugin by going to Plugins, Manage and Install Plugins. And then look for Semi-Automatic Classification plugin. You will find a button that says Install Plugin. You click on that button and that's all. We have pre-processed the images as well. We downloaded them with the SCP plugin and they are Sentinel-2 images, and we have pre-processed them. We have now the reflectance values of each image and we applied the atmospheric correction as well. And then we have clipped the images to the study area region. You can find the input data in the article published in Hatari Labs. Okay, as you can see, the study area is a forest and it has a good coverage of vegetation. We can combine these bands to get a false color image. A false color image will enhance the areas of vegetation and it will contrast it as well in the image. So we can go to the SCP plugin, then show plugin, and now here in band set we are going to add the bands of the satellite image. In this case, we have several bands. They are Sentinel-2 images. We can select Sentinel-2 in the quick wavelength settings, and the center wavelength will change. QGIS will name the bands with these numbers, the numbers on the left side. So the Sentinel band 2 will be QGIS band 1. Band 3 will be band 2, and so on as it appears in this list. So to create a false color image, we need band 8 of Sentinel, the near infrared one, this one. So this is band 8 in Sentinel, band 7 in QGIS. We also need the red band in Sentinel, which is band 4. For QGIS will be band 3. And we have the green band as well, which is the third one for Sentinel and number 2 in QGIS. So to create a false color image, we are going to to write the combination in this option of the SCP plugin. So here it says RGB, and we are going to say 7, 3, and 2. Then we activate the virtual band set, and here we have the false color image. As you can see, the vegetated areas are the ones in red. Okay, so we also have used the reflectance of each band to calculate the different vegetation indices. We have calculated the NDVI and the NGRDI, which is an index of visible reflectance, and it is used with the RGB, or red, green, blue, of an aerial camera. This index is not very used in comparison to the NDVI. The NDVI tends to be more used because it uses the infrared region of the spectrum as well. Okay, so to calculate the NDVI, we're going to use the SCP plugin, and we're going to band calculator. In this band calculator, we are going to write the expression of the formula, and the NDVI formula is the near infrared region or near infrared band, which is band number 8, this one, then we use minus the red band, which is band 4 in Sentinel. And then we're going to divide this by the sum of band 8, the near infrared one, plus band 4, the red one. Okay, and now we are going to run, and we're going to save it as NDVI. And now here we have the NDVI raster. We can change the properties of the NDVI raster. Single band pseudo color, and then use a different color run. So the values closer to 1 are going to be the values with vegetation, and the values closer to 0 are the zones of bare soil. So I'll invert color ramp, and the red areas will be the areas with more vegetation. Okay, so as you can see, the red areas are the areas with more vegetation. The NDVI is the normalized differentiated vegetation index, and the results display the relative biomass. Through the NDVI, we can survey the intensity and the density of the vegetation. Now we can calculate the NGRDI, and we are going to use the raster calculator again. So SCP, band calculator, and the formula is similar to the NDVI, but in this case we're not going to be using band 8. we're going to be using band 3 because we are using the green band. So we are using the green band, which is band 3, minus band 4, which is the red one, divided by band 3, the green one, plus the red one. Okay, so run, and we will save it as NGRDI. And here we can see the NGRDI. We can change this, the color, and apply a different color one. So here with this index you can see that the vegetation is the one with positive values, and the non-vegetated areas have negative values. But you can see that we can differentiate it better with the NDVI. Okay, so we also have a raster of biomass. This raster tells us the biomass in tons per hectare. There are several sensors that can obtain the biomass data, and there are some drones as well. These methods are used in the field, and the biomass can indicate as well the amount of carbon in the study area. The unit of biomass is tons per hectare, and for this instance we are going to relate the biomass values with the NDVI values and the NGRDI values. To do so, we have selected some random points that are in the first area, and we are going to use the point sampling tool, where we can associate the values of the rasters with the sampling points. To install the point sampling tool, we have to go to Plugins, Manage and Install Plugins, and then look for Point Sampling Tool. I've already installed it, but you are going to have a button that says Install Plugin. You just have to click on that, and you will have the Point Sampling Tool. So in this tool, we are going to select the layer containing sampling points, which is the random points, or puntos aleatorios. And then we are going to select the layers with fields or bands to get values from. So we're going to be using biomass, the NDVI, and the NGRDI. We're going to save the vector layer, and here we're going to save it as random points biomass. Shape files. I'll save it as, say, comma separated values, and we can I'll save it as the two files. So first a shape file. Okay, so I was selecting the random point fields. I have to activate the NDRDI and the NDVI as well. And then open again the point sampling tool and select the rasters. So the ones that say raster. Biomass, NGRDI, and NDVI. And save it again. And then I'll save it as a CSV file. Okay, now we can open the attribute table of the points. And here you can see that we have biomass, NGRDI, and NDVI. And now we are going to open this table in Excel to do some statistics. I'll save this one as an Excel file. And now we can create a graph, a dispersion 1. And we have the biomass in here. And the NGRDI in the y-axis. I am going to add the trending line, and I'll present the value of R, a linear tangent, a linear tangent line. And here we have a correlation value of 0.4 between the NGRDI and the biomass. And now we can do the same with the NDVI. So here we have the NDVI and the biomass in tons per hectares. We can add a trend line as well. Present the square value, the square R value, and we can also present the equation if we want to. So here we can see that the correlation between NDVI and biomass is greater than the NGRDI relation. And now we can correlate the NGRDI and the NDVI. We can see that the NDVI and the NGRDI have a higher correlation for the vegetated areas, an almost perfect correlation, almost 1-to-1 in this area. And here we have the NDVI values and the NGRDI values. So we can see that the higher the NDVI, the higher the NGRDI as well. And this helps us to identify the relationship between the parameters and the values, and maybe if we are planning on doing some models, we can try to use the ones that have a better correlation, and we can estimate some values of NGRDI from NDVI or the other way around. So this is all for this tutorial. I hope this was helpful for you, and if you liked it, please share this channel, and I'll see you in the next tutorial.